Good morning. We are Group Galileo and welcome to our presentation today about waves. But first, what is a wave? Well, in physics, it's a repeating and periodic disturbance that travels through space and matter. In the simplest waves, the disturbance oscillates periodically with a fixed frequency and wavelength. Most people think of surface waves that travel in water, but sound, light, and the motion of subatomic particles all exhibit wave-like properties. Mechanical waves, such as sound, require a medium through which to travel, while electromagnetic waves do not require a medium and can be propagated through a vacuum.
Waves have different parts. The crest are the bumps on the top, while the trough are the bumps on the bottom. The amplitude is the distance between each peak to the middle of the wave. The wavelength is the distance between crests, a full cycle of the wave. Frequency determines how many cycles pass through a given point, and speed is how fast the wave is moving and is obtained by multiplying the wavelength by the frequency. V its formula is V is equals to lambda times F.
Under mechanical waves, there are two types of waves. The first is transverse, where the oscillation is perpendicular to the direction the wave is traveling in. Examples include trampolines, electromagnetic waves, and seismic S waves. The second is longitudinal, where oscillations happen in the same direction the wave is moving. Examples include sound waves, ultrasound waves, and seismic P waves. Transverse waves are also further distinguished between pulse and continuous waves. A pulse wave is a non-sinusoidal waveform that travels as one lonely crest, while a continuous wave is an electromagnetic wave caused by an oscillation or vibration.
And that brings us to electromagnetic waves, which are oscillations that create electromagnetic radiation and can be observed as radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays, all in which form the electromagnetic wave spectrum. As you can see from this illustration, the gamma rays to the left have the highest energy and frequency and lowest wavelength. It is a penetrating form of radiation that arises from radioactive decay of atomic nuclei and thus imparts the highest photon energy. On the right, we can see radio waves, which have the lowest energy but the longest wavelength. So long, in fact, that they range from the length of a football field to larger than our planet.
All these electromagnetic waves have real-life applications that are extremely useful for us. Radio waves, for example, transmit easily through air and are used for communication such as radio and television. Microwaves are used for heating food and for satellite communication. Infrared is used for cooking, heating, and detecting organisms in the dark using temperature. Visible light is obviously the light that we humans can see and is used for fiber optic communication. The last three are dubbed as ionizing radiation, for they remove electrons from atoms and, while useful, can kill us. Ultraviolet sterilizes water by killing bacteria in it and the source of vitamin D, though too much exposure can cause skin problems. X-rays are used medically to view bone structures, and gamma rays are used for radiotherapy, sterilization, and nuclear energy.
All waves transport energy as they travel. A wave's energy is proportional to its amplitude squared, and changing the amplitude of a wave can change its energy and therefore its intensity. We've prepared an organizer here for you to be able to remember and review the topics we've discussed today. If you have any questions, just type them below in the comments section. This concludes Group Galileo's presentation on waves. Thank you for watching and have a great day.
Morioh, radio.